shoes were initially invented or developed to protect the foot. And the earliest traces of something like shoes that were actually laced onto the foot with the strings goes 40,000 years back. Since then we came a long way, and somewhere in the way people discovered that shoes are not good only for protection, but can be used also for better purposes like fashion. It could be make you look better, taller, sexier, and some went a little further than others, and in this case, as you can see, this is the ancestor of Dr. Schultz. It looks almost the same if you look at the, except the bottom, but this is from 400 to 450 AD. It was discovered in Holland. So, you know, if you look at the principle of the foot, really haven't changed. It's still the same as it was, but there are some changes that have occurred in the last, particularly in the last 30 years, that we have addressed, which you will see later. Let's start with the foot. This is a diagram of a foot bone structure. There are 26 bones in the foot, 33 joints, 107 ligaments, and you have 19 muscles and tendons. And all this is in this complex structure that actually needs support, because without that, without support, the ligaments are not holding anymore. When people walk barefoot all the time, it's okay. Those 700-800 nerves in every foot, in each foot, are those that sends the numerous signals to your brain telling that it's tight, it's pinching, it's hot, it's burning. It's that makes it so difficult to make comfortable shoes. And we at Micropores have addressed that in a different way. When you know that 75 people have different feet from left and right, practically everybody has different foot from each other. And then you have high instep, low instep, wide foot, narrow foot. You have high arch, low arch, no arch. A lot of people with no arch, that's even more difficult. You have toes that are, big toe is half an inch longer than the rest of the toes. You have people that have the middle toe that's longer than other toes. You have people that have square toes. Everything from big toe to little toe, everything is in the same line. Yes, it is actually funny when you think of it, but it's a challenge because now we have to put all these differences and make them standard. We have to find a way to fit a population of people, at least 50%, or you don't have a good seller. And when you have true fit shoes, for men's is easier because you have laces, you have a lot of adjustments. But for women, when you have pumps and any kind of true fit shoe without any adjustments, that's difficult because one width and with all these differences, it is hard to capture the masses that way. So we did a little bit of study, and we addressed the physiological changes that occurred in the last 20, 30 years back. You all are in that sneaker generation. Our parents and grandparents grew up in tight shoes, those that had them. But all of us grew up in very comfortable shoes, and because of that, the foot has spread. Also, the generation that we have now, population is much heavier than it was 30 years ago. That also causes the foot is bigger. Yet most of companies insist that the standard for shoes, because it says in books from the 60s, is this measurement. We made our B width, actually our medium width, a C width. So our volume of a shoe is approximately 1/4 of an inch bigger than most of the companies out there. And it has proven to be very successful because it now fits a different portion. If you imagine all the population a circle like this, and then you have narrow here and wide here. We have just shifted now to capture a big portion of the wide width and abandoning the reducing number of the medium width. And I think that has been quite well received on the market because I'm not getting too many complaints of fit anymore. Another big factor that we have is Micropores is very understanding designer. I worked with designers before, and anytime I had managed to put foam under the foot, it was heresy. It was to the point where some people didn't want to see me around. when I came to Michael Kors, I had the first meeting with them. I went to the proto review, and Michael says, look at the shoes, and we're going to have foam in here, right? I thought he was mocking me, you know, like, hold on. So I'm standing there quietly, and he says, I want the foam in these shoes. Can we have it? Well, hell yes. It's a lot easier to make comfortable shoes, and comfort really does come, especially when you have the high heels. The center of gravity shifted, and when you have that, you have to add something to compensate for that. Shock absorption, very important. If you have Birkenstocks, you know, they're hard. There's no cushion there, but it works well because of the anatomical. When you change that, you have to then compensate for what you have taken away. Some interesting facts about shoemaking. 200 to 250 people will touch every shoe before it's finished. It's very labor intensive. It's actually one of the most labor intensive products on the market. Consumer products, absolutely. In some cases, even a lot more. It takes about 50 to 150 minutes to make of effective work. Effective work means that only when something is changing. Imagine effective work would be when you cook. Effective work when you're cutting and chopping. When it's on the stove, that's not effective work. It does by itself. And that's the same with the shoes. Then that turns into production cycle. From cutting, when the leather is cut, until the shoes are in the box, it takes 4 hours the shortest. That is particularly well developed in Brazil, and 2 to 3 weeks in China. 15, 20 years ago, that cycle in China was 5 to 6 weeks. It took a long time from the time that they cut and packed the shoes, particularly because they couldn't coordinate components. There's a lot of components in shoes. You know, when you look at everything, you probably have over 150, 160 parts. And to get all those together in time didn't exist like today, the just-in-time production planning. When I started working in China, very interestingly, they started cutting, and then they just went along. How many people I need now to stitch? They said, I have to do 2,000 pairs a day. They cut it 2,000 pairs, and then they went and tried to figure how many people they need to stitch. And by the time they were through the first 2 weeks, they figured out that they could cut 5,000 pairs, but stitch only 500 pairs, and then they could last 2,000 pairs. And nothing came out. So, you know, that is now in China also. It is a very well organized production. A typical factory has 3,000 to 10,000 workers, and they will produce between 3 and 10 million pairs of shoes per year. Shoemaking process. Shoes are made in 3 stages. Cutting and edge preparation, assembly and stitching, and then you have lasting, finishing, and packing. Of course, there are components. The components come from other suppliers. Very few have that in the factory. It used to be that everybody did everything, but that proves that it's not so productive because imagine you have to make a car and tires and engine, and if you do everything yourself, you have to have experts in everything. It's so expensive that the shoes would cost 5 times as much. But when that is separated out, the factories have insole experts, and the machines are for insole only, and then they distribute to different factories. Before, everybody was doing it for themselves. Use the machine only 5% of their effective possible time, and investment was the same. So they don't do that anymore. In Italy, they're so diversified that you have one operation becomes a company. People do. I'll show you later on. We have some printing where you have a factory that does only that operation, and they're extremely successful. The guy drives Ferrari, and they do only one thing. They have like 6 machines in there on one side and 12 on the other side. And when I went in there, I said, well, how can you survive on this? Not only survive. When you have that specialty, he is the best in the world. And that's what they do. They become so good that everybody wants to buy from them. They charge a lot of money. And in China, that specialization has actually enabled us to get better prices. Leather is the most important part of the shoe. We, at Michael Kors, pride ourselves particularly on 2 things: leather and hardware. And leather, in particular, is the most difficult part because it's so different. You know, it can be diversified by the origin, animal origin. As you can see, it can be cow, sheep, goat, pig, deer, buffalo. There are plenty exotics, snakes, alligators, crocodiles, ostrich lizard, and all kind of furs that we have. And we can have aquatics like shark, stingray, and sometimes skate. The other classification is by the process, or as we know it, by surface. Full grain, like our vaqueta, suedes, split suede, nubuck. The difference between suede and split suede is that suede is reverse leather. If you look at the leather, you have the smooth side and you have the flash side. If you just reverse it, is the suede. Then split suede is when they split the skin, which is thicker. They split the skin, and then whatever falls off the bottom of the dermis, they use that, and the top is then prepared as a suede. That's called a split suede. Patent nubuck is a full grain leather that is buffed at the top. And you get a little nice nap on the top of the surface. Patent is the same leather. Usually they use for patent would use lower grade skins, and they buff the surface off. They paint it, and then they put PU coating on top. Embossed leathers are like Croco, Snake Emboss, or our Saffiano is embossed leather. Same thing, they use lower grade leather for that, because when they press the plate with a pattern on, you don't see any defects on the skin. Specchio is our mirror metallic. You have corrected leathers, which are basically same principle as patent. They just put more rubbery surface rather than the patent. Then we have hair calves, shirling, pull-up, oiled, washed. Washed leathers are basically just put in wash and let them dry. Depending how you dry it, you get those effects of like washed jeans or washed fabric. Have metallics and all kind of novelties. We don't use a lot of novelties, but you can see them in the market all over the place. Here you see two diagrams. The left one you probably see from Mike when he was presenting with the handbags. The skin is divided in 5 sections of quality, going from 1, the best, to 5. For shoes, we have to look a little bit more specific, because for handbags, when you look at how the handbag is made, it's made geometrically. If you take a piece of leather and you fold it together this way, and you have 2 more pieces here, fold them this way, and you stitch that together, the bag is finished. For us, that's only an upper. That's the first stage of making the shoes. We have to then transform that into 3D shape by forcing it over the last. And when we do that, it is pulled. It's actually literally stretched in the last. These arrows here represent the least stretch in the leather. And our shoes all have to be cut tight heel to toe. The arrow represents tight heel to toe. Anything that you see, all parts go heel to, except the plug on the Vans or moccasins. Those have to be tight across, because if you don't, when you last the shoes, they stretch and you can't control the shape. But if you had, for example, you had a Vans that you cut here, that is part this way and part this way, this will be okay, but this side will stretch. If you put it on the last, inside is okay, the outside is not, it's loose, and you have top line loose. We can control that somewhat with backers and reinforcement, but the best way is if shoes are cut exactly the way those arrows show. Here you see a person actually preparing a pattern how these pieces have to be laid to have minimal waste, and still considering how the parts will be cut based on the direction of stretch of the skin. The next slide shows the typical cutting machine in China. They use the half bridge or one-arm cutting machines. The way this operates, as you can see there, it has two handles. They have to bring it over, press 2 buttons after they put the cutting die, of course, on, and then after they press 2 buttons, that goes down. They used to do that with one hand only, but then, especially when they have piecework, they were rushing. Somebody they forgot to take the fingers off the cutting die, and along with the leather, the fingers came off too. So now it's illegal anywhere in the world to have a single hand cutting machines. Another interesting fact is you see here, you have a cutter there and you have an assistant there on the side. All the cutters are men and all the assistants are girls. That's not because they think in China the girls are better, men are better than girls. But these are all migrant workers. And when they migrate, they don't come there like they used to come from Europe to the United States to stay. They come there for a year, for 2 years, to save some money. It used to be 15 years ago, they came, as long as they had $1,000, that was enough. $1,000. They went home and they opened a little kiosk, and that was dowry, whatever it is, and they went back home. Now, of course, that's a little bit more, but it's still nothing in our terms. But for cutting leather, it takes a lot of skill, and it's very important. It takes 2, 3, 4 years to learn. If they stay only 2 years, they can't be there. The guys come and stay for longer. They come there to make money and send home. But what they do is he cuts the leather. He's the expert now. He knows how to cut the leather with all the how to place the knives, how to cut the stretches, and that girl there will mark every single piece. When we have different textures, crocodile, or you have even hair cat, or you have different colors, you have to cut in pairs. And that girl there will mark every single piece with the identical number, and each pair then goes into production, marked with those labels all the way through, so it's never lost. When it's stitched together, you can see every single piece has that label on with the same number. Here's an example of new technology. This is a computer cutting machine where even more skilled workers than those that cut leather will prepare this digitally. They just project the parts on, and they would put them on all together, save it in the computer. Then they go on the other side, prepare a different skin, and the computer will cut by itself with an oscillating knife. After the pieces are cut, we have to prepare the edges. We have to sky them to make edges thinner, so that doesn't hurt, that doesn't x-ray through the upper, the parts that are laid over. We fold the edges. They have to be painted in some cases. They have to be marked. A lot of parts have to be marked for assembly allowance. When you have shoes that have different parts stitched on top of each other, it's very important if you put, typically it's 8 millimeters, that's the allowance. Now if you do 10, that's a quarter size smaller shoe than would be otherwise. If you do only 2, that's 2 millimeters less, that would be quarter size longer. So it's very precise. And with shoes, handbags, if the strap is an inch longer, who cares? If the bag is half an inch wider, who cares? For shoes, an eighth of an inch and you're done. You're done. It doesn't fit anymore. It's over. We do the laser cutting in this stage, perforations, crimping, backing, and studs application. I brought this, for example, the stud application. This is all done by hand. This shoe, or when it's a pair, this has exactly 2,960 pieces. It takes over 1.5 days, one person to do one pair. Even in China, it costs, believe it or not, but this was out of Europe, this would cost the same if it was made in alligator. But it's no other way. It's done by hand. It's all marked. Everything is laser cut, so it's all precise by computer. Otherwise, it would be all over the place. And that is done one by one, in and put with a special tool, hammer it in. It's quite a sight when you see when they do this. Luckily, we bought only 1,000 pairs. Yeah, if they bought 10,000 pairs, we would deliver them by Christmas, not in July when we have to ship. This is a typical stitching room. You see that the trays here represent one pair, in some cases half a pair, and all those parts that were cutting before that are marked with numbers. As they go through skiving and painting, all those can get separated, but they mark them back match them back by numbers, put them in these little trays, and then they go down to the bare line for the stitching. Now I'll show you the crimping. That's one of the biggest differences between what we do in shoes and what we do in handbags. In handbags, leather is not basically torture. It just transforms. We literally have to transform leather from 2D to 3D. And this is flat upper with the back, and then we have to get into this shape. This is done by literally forcing it through a series of machines, depending on the heel height. Lower heel height requires less, this is particularly the boots. When shoes we don't have it. Every time we have the boot, we have to print to get this shape because it's impossible to do only through elastic. You can do that also if you have the seam down the center. But nobody wants those seam down the centers in the boots anymore, so we have to do printing. This is that operation I was telling you that the guy has 12 and 6 machines that does pretty well. This is the machine. It has 2 panels at the side, as you see, and a bar down the middle. The vamp is placed underneath, over top of those 2 panels, and then the center bar lowers down into the gap in between and stretches the leather over those panels. Sometimes this has to be done 4 or 5 times, depending on the type of the leather, depending on the heel height. If you went from flat to the final shape, all you would get is brick leather. So it has to go very slowly. You have to go a little bit, let it relax, and then a little bit, and let it relax. You can't even go from one to another to another to another. And that we have different machines with different curves on these panels. It's a very delicate, and sometimes when you see particularly on the wedge stem leathers and the gathers, you see the little line down the middle. That's what it is from. Then all the parts have to be marked. This is taken directly from production, so very spectacular picture of what it shows. It's done by screen printing. In Europe, other parts of the world, what they do, usually they have a machine with a row of letters and numbers, and they set it with proper sequence, and then the stamp. It's always, you can see here, it's always one line. We have to, by law, stamp made in China in the shoes. And we have to stamp whether it's an upper or man-made upper. The same for the outsole. And then we have the size, the width, and the numbers there on the side, not very visible, represent the factory code and the month and the year where the shoes were made. If you want to know when it was produced in the factory, you can see the year, it's the number, and then the months go in alphabetical orders, A, B, C, D, they just count. January is A, and goes so forth. Here is an example of marking. This is a small piece that is for buckle strap. But this is what we need to do. Sometimes for stitching, we need to mark where exactly it's stitched. This, what you have over here, this represents, I don't know, is this one? That little line in the middle is where the buckle elastic will go through. The other 2 lines are where the strap will come over this little strap. Here's an example of folding. This is done by machine. Mostly in China they still do by hand, but labor is getting too expensive, so pretty soon this will be replaced by machine all over the place. As you can see here, you have a little nozzle on the side where the thermal cement is coming in. There's a hand that folds the piece of leather over, and there's a tape plate right into the edge. So you get the reinforcement and you get the folded line at the same time. Zippers, as you know, we use a lot of zippers. I think that nobody in shoe business uses more zippers than we do. It is quite complex. It's a lot of work to put all this together. You know, everything is done by hand. The zipper has to be cemented, upper has to be cemented, then it's done by hand. Then we put the zipper stopper at the bottom, 2 zipper stoppers at the top. A lot of work. So if you imagine this, what it is, just here is 5 to 10 people that will do to get all the way through between the zipper onto the outer. This is now assembly of that little piece that we saw before. The buckle, that's a little strap over there, on which the buckle is placed through the prong, and then that is inserted into the strap and is stitched then together with that automatic machine. For this, you can use automatic machine because it's always the same. You just program the width and it goes straight. You can do that. Most of the things are done by hand. This is an example of a strap. There's elastic on the inside. That elastic is, the way we do that is elastic is stretched leather is first is cemented, the leather is cemented, the elastic is stretched, glued onto the leather, let go, and then you get that those wrinkles, and you can stretch it back. So it gives a little bit, relaxes a little bit as we walk. Here's an example of stitching. I use this particular picture because it shows this is really difficult, because we use so many studs, we have so many ornaments. The way the stitching machine works is it has a wheel there, it runs on top of the leather, and then it will stitches. If you have studs down the middle, you can't do that because it will go all over the place. So we have to use this plastic strip to put on top of the studs, and the workers, here you would want to have the third hand, because it's to hold the whole thing and then guide it through and go straight. It really almost looks like you need the third hand. It's not easy. Then all the linings have to be trimmed. In China, they're still doing that by hand. There are machines. In Europe, everybody does that with machines that set on and it's trimmed automatically with as they stitch. This is one of the most important operations in shoe business. In the old times, hammer was used all the time. Now, if you give somebody a hammer, they can go through a career of 40 years and you have a couple pens on. For some reason, people don't like it, but it's a big difference. If you look at here, this is the top line of the drop top line up. As you stitch, every time the needle goes through the leather, it pulls a little bit and it shrinks the upper. The best way to get it back in proper shape is by hammering, not by stretching it and pulling, because it doesn't do it even. And in the old times when people were making shoes by hand, every part of shoe was hammered on the elastic, every part, all over. They would use this heating pad, sometimes you would open fire, they would heat the leather a little bit, and they would tap it all the way around. It was almost like, you could see that they loved the shoes. Now, this is industry. They do that because they have to do, not because they love to do, and it's difficult to do. But when you have shoes, all those edges around the top, it hurts. It's usually because it wasn't hammered. All the straps when you have, you feel the threads underneath. If it's not hammered, it hurts. All the sharp edges, hammer can take all that away. It can do so much, but unfortunately, people factories don't do that anymore. Now we go to elastic. This is where the uppers are actually made into shoes. To do that, we need elastic. The elastic presents foot. So the elastic represents now the average measurements that we decided to be a standard. The back parts we standardized. The front changes as the fashion changes, or our designers want is pointy, tall, shallow, round. However they want to have it, the back part is typically the same. The down curve, which is the pitch of the shoe, is also standardized because it's very important. Otherwise, you have to make new molds for every different insole, and it would be way too expensive. The piece at the bottom is called insole, and that is the foundation of the shoe. It has the same function as the shoe as the foundation has in the house. If the foundation in the house is bad, the house will go over. Same for the shoe. If the insole is bad, it's unstable. It's not going to stand straight, it's going to be difficult to walk, and it's sometimes even dangerous. Then, before we go into lasting, we have to mold the counters. In this case, we use thermoplastic counters, which are heated on the separate lasting, and then they put this frozen. This is actually the white on there is frost. And then that cools it on the shape. The shape of the last layer is almost the same as the final last, but it's not precise. It's just regular heights. We're going to have too many. And the top you can see is a rubber mold that will press down and form it into the shape. Then we go to the toe lasting machine. This is where the shoes are lasted. That's quite a contraption. This machine costs about $100,000 US. As you can see here, the upper is placed on that last over, and the insole is on it. It's sometimes cemented at the bottom by hand. Sometimes it goes automatically. You see here the little white. There's a cement that white in the top left corner. It is filled with cement is fed directly into the machine. So what it does here is you have 4 sets of pincers there, 4 on each side, 4 pairs, and then it's a center on the front. So the front one, the side ones, and those pincers then pull down. Underneath, which you don't see, is it's a stand which lifts up at the same time, so it stretches the leather evenly all over the last. Then that white piece in front of it, which is called Teflon toe band, that has to be done for every last precisely, because when it closes, it has to close very tight around the last and holds the leather in place. As those pieces go, the shares come in, and then you have closes here, and then you have final last shoe like this. This is called lasting margin, and that is where the shoe is cemented. That is enough. You have there, you need just about ½ an inch, a little bit more, and that's enough to have the outsole to stay on the shoe. In this case, what you can see is a very pointy toe. We can't last the toes without having those heavy wrinkles that have to be hand cut off and prepared for further production. The sides are typically lasted by hand, and then goes into the back part lasting. The orange thing is called the saddle. It fits exactly around the back part of the last and prepares the heel seat. See, why is that important? Because if that is not straight, as you can see, this is very sharp edge around. The heels will not sit straight on, and you will see all the gaps around it. An interesting part of technology where it is today, some factories have ring systems, and the toe lasting machine that you see before is the last person that will touch the shoe before they lay on the outsoles. What they do is they have the toe lasting machine, and then the same worker was, as they finish here, they would just turn and put it into the back part lasting machine, into this one, and then from that, robots take over. The robot will take the shoe out, and each of those machines will last half of the shoe, no hand work is in between. The robot hand will take it, put the machine which does automatic wrapping, instead of by hand as we do here. And then from there, another hand will take it, pick it up with another machine, will be applied to cement. This again is done by hand. You can see the little traces of blue, that's UV agent in there. We have black lights. That's the reason for that is so the workers can see that the cement is all over the place. Cement used to be yellow because they're all neoprene based, more organic. Now it's the PU cements, the water-based cements, they're all clear. And when you have a clear cement, you have no idea where you put it, where you did it. So we had to put this UV agent in that you see exactly where it is to not have any problem issues. Another big difference between handbags and shoes. We have to put shoes in heat setter. Because when shoes are lasted, there's a lot of stress on the leather. And when they pull it, the fibers break apart. Heat setter then at 220 degrees for 10 to 12 minutes, depending on what type of leather it is. Sometimes less, sometimes a little more. But what it does is it solidifies those fibers again. In the old times of production, they used to use what we call muller. They would put uppers into a special room for 24 to 48 hours. And that was 99% relative humidity at 100 degrees Fahrenheit. It was literally like a tropical green room. You walk in there, it was a fog. And that what it would do is, without condensation, the upper leather would absorb the moisture. But then you have to have it on the last for 24 hours. Today, nobody can afford it. You don't have time. Our shoes are on the last maximum an hour and a half. Then they come off. And at this time, they have to set. If you don't have it set, they will be still moist, they will collapse, they will shrink, and you can't control the shape of the last. So that's why they go into the heat setter. After the ounces are on, we put them in the chiller. And what chiller does is shocks the fibers so they stay and they don't move anymore from there. Also, it helps us cool off the last because those plastic lasts, when they go through the heat setter, they're pretty hot. And whatever's outside cools off, whatever's inside the shoe stays hot. And the next round, if they go around, it'll be very difficult to work with those hot lasts. Here's an example of outsole laying. That is by hand, it will always be by hand. I don't imagine there will be ever a robot that will put that on for us. Also pressing, very important. You see that yellow part underneath. Each construction has a negative made in that silicone mold. So when they put the shoes on, they have equal pressure on every part of the shoe all the way through. And then the shoes are being finished with cream or any kind of finish that we want to put on, polished, and packed. So just a quick preview what we'll do in June. I will introduce you to some constructions. I'll bring some, I have a box prepared, but I'll bring that next time. And we'll talk about anatomy of the shoe, okay, fit paradigm, a little bit more in detail, comfort factor, and